Okay, I just wanted to follow up Wednesday's lecture with just a few of the examples that are in this chapter. So I'm on page 42 of the notes. I skipped a few pages because we'll go over those on Wednesday, but I just wanted to make sure I've honed in on the main points. So if we look at matrices A and B here, so actually I'm going to think of this as the matrix A, maybe I should say that. So if I look at this as the matrix A, and let's call this C, and we'll look at this as the matrix B, and we can call this D, okay? How many rows of A have a leading one? So if I look at A, I would say that the leading ones are here and here. So 2 rows of A have a leading one. So 2 rows have a leading one, and that's the same for B, 2 rows. How many columns of A have a leading one? Also 2, because each row that has a leading one also has a leading, that corresponds to a column that has a leading one. So I have 2 columns of A. So the columns, I'll do maybe in yellow. So the second column and the third column, the second column and the third column have a leading one. So again, 2 and 2. How many leading ones does A have? How many leading ones does A have? It has 2. How many leading ones does B have? 2. Right? And imagine that A corresponds to a system of equations. How many solutions do we have? So since we have a column that doesn't have a leading one, namely this column and this column, what that tells me is that since the columns 1 and 4 corresponding to variables x and w have no leading one, so they are free variables, which may make me think that there are going to be infinitely many solutions, which could imply there are infinitely many solutions. But in fact, let's do that in pink, but if we look at the third row, it's 0, 0, 0, 0, bar 1. And what that tells me is there are no solutions. Okay, so this nasty row here trumps the free variables. It forces the system of equations to have no solutions. Notice that when I'm over here, that same row is just a row of zeros. So whereas in question number 4, columns 1 and 4 correspond to free variables of A, they also correspond to free variables of B. But when I'm looking at matrix A, this row of zeros followed by a 1 gives me no solutions, whereas this system would have this system of equations has infinitely many solutions. Okay, so whereas the A has no solutions, the B has infinitely many solutions because I don't have the row of zeros followed by 1. So if we ask ourselves, suppose that a system of 9 equations in 7 variables has an augmented matrix that when put in row-reduced echelon form has 4 leading ones. Okay, so we've got a system of 9 equations and 7 variables, right? So my matrix is going to look like, so I'm going to have A equals some B, and it's going to look like, when I put it into a matrix, A bar B, where A has how many rows? I've got 9 equations, 9 rows, and I've got 7 columns. So it's sort of it's going to be sort of like this. It's going to be long and skinny, right? So I have more rows than I have columns. So describe the solution set if one of the leading ones is in the rightmost column. That means I have a zeros. So that would mean I have zeros followed by a 1 in the rightmost column. That means on the other side of the B. And what that would tell me is there's no solutions. And describe the solution set if none of the leading ones is in the rightmost column. That tells me I have infinitely many solutions. Okay. Or what? Or 1 solution. Okay. None of the leading ones are in the rightmost column. So I could have rows of zeros with another 0 over there. Okay? So suppose that a system of 9 equations and 7 variables has an augmented matrix that when put in, oh, this we've already done, that's the same. It's the same question. Find a cubic polynomial that satisfies p of 0 equals -1, p of 0, I repeated it, p prime of 0 equals 5, p of 1 equals 3, and p prime of 1 equals 1. So let me see if I can add a page here. So add page. Okay. So working on number 2. So we've got p of x. It's a cubic polynomial. So we've got a plus bx plus cx squared plus dx cubed. And I know that p of 0 is equal to -1. So plugging that in, I get a plus b times 0 plus c times 0 squared plus d times 0 cubed. So that's just a. I know that, oh, I know what this was supposed to be. No, that was just, I know that p prime of x, so that's the derivative, is b plus 2cx plus 3dx squared. And I know that p prime of 0 is equal to -1. So that's going to be b plus 2c of 0 times 0 plus 3d times 0 squared. So that's just b. And then I know that p of 1 should be 3. That came from up here. P of 1 should be 3. And that equals a plus b times 1 plus c times 1 squared plus d times 1 cubed. So that gives me 3 equals a plus b plus c plus d. And then p prime of 1, looking at this equation, that should be equal to 1. So I get, now I'm plugging in to this equation here. So I get b plus 2c times 1 plus 3d times 1 squared. So I get 1 equals b plus 2c plus 3d. So that is corresponding. This equation here came from here. this equation with the 3 in it came from the p of 1 equals 3. The equation 1 equals b came from p prime of 0 is 5. Ooh, p prime of 0 should have been not minus 1, so this should be not minus 1, but 5. Good, we checked our work. Let me highlight that again, right? And then last but not least, this first equation, p of 0, oops, this first equation, p of 0 equals minus 1, that's what gave us this equation here. So now let's pull all those equations together. It looks like we've got 4 of them. So I have a equals minus 1, b equals 5. I've got a plus b plus c plus d equals 3. And I've got b plus 2c plus 3d equals 1. So putting that in standard form, I get a equals minus 1, b equals 5, a plus b plus c plus d equals 3, b plus 2c plus 3d equals 1. That's my system of equations. I can make it into an augmented matrix. A 0, 0, 0, minus 1, 0. Oh no, a is my variable, so that's just a 1. Right, so let's make a comment that my variables here are a, b, c, and d. So I'm really looking at the coefficients here. So that's why I have 1 corresponding to the a plus 0b plus 0c plus 0d. Then 0 times a plus 1 times b plus 0 times c plus 0 times d is 5. And then 1 times a plus 1 times b times 1 times c, 1 times d is 3. And 0 times a, 1 times b, 2 times c, 3 times d equals 1. And there's my matrix. I put it into row reduced echelon form, and then I translate to the solutions. That's how you would do that one. All right, enjoy.